So hello everyone, let us solve today's GFG problem of the day, and the problem name is largest pair sum. So we need to find the largest pair sum in an array of distinct integer. So what does that largest pair sum means? That means we need to find the maximum element of the array and the second maximum of the element of the array, and just we need to return the summation of these two numbers. So for example, in this first example you can see the maximum element is 40 and second maximum is 34, so summation will be 74, so we return 74. So this is what we need to return, and we need to do this in O of n time complexity and O of 1 space complexity. So let us see how will we do it in linear time. So let us say we are given this array and we need to return the largest pair sum of this array. So one way is that we can simply sort the array, and the resulting array would look something like this: 6, 10, 12, 34 and 40. Sorry for that, it would look something like this. And to return the largest pair sum, the largest number would be ARR of n minus 1 and second largest would be ARR of n minus 2. See, we just return the summation of these two. But this approach is right, but it would take the time complexity of n log n, but we don't want to do that. We want to have our solution in the time limit of O of n. So let us see now how we can achieve this in O of n time. So just think how we can find our maximum element in just single iteration. So what we can do? Simply we can just assign our maximum element to be as minimum as possible, because we want to compare it with all elements. So we can assign this initially to int min. Now what we can do, we can traverse the array and we can just compare this maximum with our current ARR of I. So what we can do, in our iteration we can just have one check that if ARR of I is greater than our maxi, it can't be equal because they have given that all the elements are distinct, so no element can be repeated. So if ARR of I is greater than maxi, we will update our maxi to be ARR of I, and we will continue doing until we reach the end of the array. So first we will be at 12. So yes, 12 is greater than our current maxi, so we would update our maxi to be 12. Then we would come to 34. So yes, 34 is greater than our current maxi, so we would update our maxi to be 34. Then we will come to 10. So 10 is not greater than 34, so 34 will be remaining as it is. Then we will come to 6. So 6 is not greater than our current maxi, so our 34 will not get updated. In the end we reach 40, and yes, 40 is greater than our current maxi, so we will update our maxi to be 40. So here we will get our maximum element of the array to be 40. So this is how we will get the maximum element. But how will we find the second maximum element? So let us see that now. So we will do the same thing for the second maximum element also, but we will add additional one condition. So same way we can have one second maxi variable. Second maxi, it will be initialized again to int min. And what we can do, we can again iterate our entire array, and we can have one condition that if ARR of I is greater than second maxi, as well as we will have another condition that this ARR of I should be less than our maxi. So and this ARR of I should be less than our maxi. Then only we can update it to our second maxi equal to ARR of I. So what will happen if we would not write this condition? If we would not write this condition, eventually it will give up the maximum element of the array, but we don't want that. We want just lesser than that but as great as possible. So this will give us the number as great as possible, but this will give us just less than our maximum number. So eventually it will end up giving the second maximum element of our array. So let us see on dry running on this example how we can get the second maximum element of the array. So initially we will be traversing at the 0th index. So we will compare our second maxi with our ARR of I. So yes, 12 is greater than our second maxi. So our maxi would be stored in our maxi variable. So we will also keep check of that. So our maxi is 40. So it will check, is ARR of I greater than our second maxi? Yes, it is greater than our second maxi, as well as it is lesser than our maximum variable. So it has a chance that it could become the second maximum element, because all the numbers are distinct. So there is no possibility that we can have same maximum two times. So it is not possible. So it can be it can have a chance that this can be our second maximum. So we will update our second maximum to be 12. Then we will come across 34. So we will again check, is 34 greater than our current second maxi? So yes, 34 is greater than 12, as well as 34 is lesser than our maximum number. So yes, it is a chance that this 34 can become our second maxi. So we'll update our second maxi to be 34. Then we will come to 10. So we will compare, is ARR of I is greater than our second maxi? So this condition failed here itself, so it will not check this. So our second maxi will not update. Then we will come to 6. So it will again check, is 6 greater than 34? No, 6 is not greater than 34. So again it will not check this condition. So then we will come across this 40. So it will again check, is 40 greater than our second maxi? Yes, 40 is greater than our second maxi, but this 40 is not lesser than our maximum element of the array. So it is not possible that this could become our second maximum element. It is greater than our second maximum, but it is equal to the maximum, so it can't become the second maximum. So our second maximum will not get updated, because this condition will get false, and eventually we'll reach the end of the array and our second maxi would be storing 34. See, we got our maximum till now as 40, and we got our second maximum as 34. In the end, what we need to do, so let me just erase this. So in the end, we just need to return maxi plus second maxi. So it will turn out to be 40 plus 34 equal to 74. So this will be our final answer. So that is how we will do it. And since we did the linear time, since we do only single iteration for the maxi, it will be O of n, and we did single iteration for the for finding the second maxi, it will again be O of n. So it will be end up taking O of 2n. But since this is constant, so we can neglect that, and our final time complexity would become O of n. And we didn't use any extra space, so our space complexity will be O of 1. So this is how we will solve this question. So let us directly write the code now. So let us write the code now. So initially we will define one variable integer n. So int n equal to ARR dot size. So it will store the size of the array, and first we will find the maximum element of the array. So for that we can initialize our maxi to be int min, and we can now iterate our entire array. So what we have seen, if our ARR of I is greater than our maximum element till now, so we will update our maxi to be ARR of I, and it will keep on happening until we reach the end of the array, and in the end we will have our maximum element in our maxi variable. Then what we need to do, we need to find second maximum element of the array. So we will declare another variable sec maxi. It will be again initialized to int min, and we will again iterate to the entire array, I equal to 0 till I less than n and I plus plus. Now we will again have the condition of if check, if ARR of I is greater than second maxi, as well as this element should be less than our maxi, then only we can say it is our second maximum element. So if this is the case, update our second maxi to be ARR of I. So it will keep on happening, and eventually in the end, after iterating the entire array, we will have our second maximum element in our sec maxi variable. So in the end, what we need to return? We need to return the summation of both of them. So return maxi plus sec maxi. So yeah, this is how it will run, and let us see if it get accepted or not. So yeah, our code got accepted. So hope you learned from this video. Thank you.